Hello everyone. In this video, we will see the operation, waveform and the calculations regarding the buck boost converter. In the previous video, I have discussed about the buck converter, boost converter. Also, I have discussed about the class A, class B, class C, class D and class E chopper. And then we move to buck boost type of choppers. Now, buck boost converter means in this circuit, this will act buck converter also, boost converter also. That operation we will see. You can see the playlist named the power electronics in my channel. Okay, now we'll see the operation. And this is the circuit diagram, simple circuit diagram that you can see that it is the VDC, that means DC source. Also we write it as VS, that is the source voltage, and here the switch is connected and inductor is connected over here as you can see, and normal PN junction diode that is connected D. Okay, and capacitor is connected and resistor is connected, and across the resistor the output voltage is taken. So output voltage is taken across the resistor. So we will see the operation. The operation, that is when the switch is on, that is SW switch, that is in the on condition. When it is on condition, then it will be short circuit. So whenever it will be short circuit, the circuit diagram will look like this, inductor will be like this. Okay, so as you can see, it is VS and it is the inductor L. So the current will be flowing like this, positive terminal to negative terminal of the supply voltage, and inductor will getting charged like this. One will be the positive polarity and this one will be in the negative polarity. Okay, now as it will follow this path, so no current will be passing through this, as also this diode will be in the reverse bias condition because positive terminal is connected to the cathode, but negative terminal should be connected to the cathode and positive should be connected to the anode to make the PN junction normal diode forward biased. So it is reverse biased, acts as open circuit, so no current will be passing from this. Now capacitor voltage, we see that the conventional direction, that is IC, up downward, the current direction will take, and V0, that is, it is upper one is the positive polarity and lower one will be the in the negative polarity, that is the conventional direction. Okay, we will apply this direction only. Now capacitor is previously charged, so the current that will pass through output, let us assume that is I0. Okay, so as we have discovered in the previous video that we will have to apply the VL on, VL off, then IC on, IC off, then only we will be able to apply the volt second balance and ampere second balance in case of the inductor and capacitor respectively. So VL on, VL ons mean in the switch on condition, what is the voltage across the inductor? You can see simply KVL, or simply this terminal voltage equal to this terminal voltage. So output voltage will be, the voltage across the inductor will be the supply voltage following the supply voltage. Okay, now let the duty cycle be D. Let the duty ratio or duty cycle that is going to be in the D. Okay, so if the duty cycle is D, then the switch is on like this and switch is off like this. So T on is equal to T into D or dt. T is the total time period and duty cycle is the T on by T. That means the ratio of the on time period divided by the total time period. Okay, so the off time period will be T total time minus on time TD. So if you take the T common, T into 1 minus T. Okay, I hope this makes sense. Okay, now whenever the switch is in the off condition, whenever the switch SW that becomes in the off condition, so what is the circuit diagram? Circuit diagram is like this. It is the inductor, then the diode is like this. Okay, you see the capacitor, forget about this, you see the capacitor, and resistance is connected over here, it is L, this is D. Output voltage is taken across the resistor. Okay, and as per the conventional direction, the capacitor current is downward and the resistor current to the resistor or output current, this is also in the downward direction. Okay, now the inductor was charged across this polarity positive and this polarity negative. So inductor, it is the time inductor to discharge. So when inductor discharges, I also explained the reason inductor reverses its polarity by using the Laplace transform. We saw that inductor reverses its polarity. So because inductor does not allow sudden change of current and capacitor does not allow sudden change of voltage. Okay, so this one will going to be positive and this one will going to be negative direction. Okay, it reverses its polarity. So if it is this is positive and this is negative, so current will be going like this from the positive terminal to the negative terminal. Okay, so capacitor current, ideally capacitor current should move like this from lower one to upper one, that means upward, but as per the conventional direction we will see like this. Okay, now the VL, so we applying at the VL, we will make sure that this is positive, this is negative, because when we will apply the volt second balance, that means VL on into T on plus VL off into T off equal to 0 in case of inductor, because in case of the inductor, whatever energy that inductor is getting stored in the case of the inductor, that amount of energy will be delivered. Okay, no amount of energy will be stored. Like inductor is storing 20 joule, let's say, energy, so it will deliver to 20 joule in the off condition. Okay, that is the volt second balance. So that is the volt second balance in the case of inductor. That means the average voltage across the inductor, that is going to be equal to 0. So if it is 0, so VL off, that is in the same polarity, otherwise the formula would have changed, that will be like minus, otherwise the formula would have changed. So we have treated the formula like plus. So VL of direction should be taken as positive and negative. So although inductor reverses its polarity, but while we will applying this formula, the VL direction should be as per the same as it was in the on condition also. This one, upper one will be positive and lower one will be negative. If you take the opposite one, then your formula will be getting changed. Then the formula would have changed to this plus will be like, in case of plus there will be minus. Okay, so VL output voltage is V0. So what is VL? So we will apply the KVL minus VL plus V0 equal to 0. So VL is equal to V0. So output voltage inductor, that is in the off condition, because switch is off, so that particular part is open circuited, no current passes through this. So VL on will found VS, that is the supply voltage. So VS into D plus, that is VL was VL off, that is V0 into T off, that was 1 minus D into T equal to 0. So T getting cancelled, so VSD plus V0 into 1 minus D, that is going to be equal to 0. So or V0 into 1 minus D, that is equal to minus VSD, or V0 is equal to minus D by 1 minus D ds. Now as you can see, V0 is overall negative, because duty cycle, maximum value of the duty cycle can be 1. So 1 minus D is always positive, D is always positive, supply voltage Vs is always positive, so this part is always positive. So negative into positive, that becomes the negative, so output voltage is negative. But why output voltage is negative? See the diagram. Output voltage, the conventional direction will take the plus and minus, but you can see in this diagram, inductor reverses its polarity, so actually current will be passing from the lower one to upper one. So in capacitor current, in that case, will start to flow from the lower one to upper one, that means in the upward direction. But as per the convenience, that is step that we have taken, the capacitor direction, as per the convenience, we have taken from the upward to downward, that means overall current direction is downward. That is the convention that is followed in this circuit. Okay, that is why the voltage is becoming the negative, that is why the voltage is negative, becoming the negative. If you take this one positive, this one negative, then that particular case will work, then output voltage will be positive. But we will take reversing the voltage polarity, so output voltage will be the negative. Okay, so V0 is this much. Now you see, depending on the D, the output voltage that can be greater than the supply voltage, or that output voltage can be less than the supply voltage. Let's say D is equal to 0.3, that means the 30% duty cycle. Okay, if duty cycle is 30%, then output voltage will be minus 0.3 by 1 minus 0.3, that is 0.7 into Vs, that will be minus 3 by 7 times Vs. Okay, that is definitely less than Vs. So in this case, output voltage is less than the supply voltage. You can see clearly, if the duty cycle will be like this, let us see 0.7, in that case V0 will be minus 0.7 by 1 minus 0.7, that is 0.3 into Vs, that will be minus 7 by 3 into Vs. And you can see, although disregarding the polarity, the output voltage, that is becoming greater than the supply voltage, so it will act as boost converter. In this case it will act as boost converter, and in the previous case it will act as buck converter. Okay, now in the intermediate case, that means the 50% duty cycle, 50% duty cycle means 0.5 duty cycle. So in that case output voltage will be like 0.5, 1 minus 0.5, that is 0.5 into Vs, so that will be equal to the supply voltage. Now you can see that is duty cycle. Based on the duty cycle or the on period of the switch or the off period of the switch, we can regulate the output voltage. That can be boost converter also, that can be used as buck converter also. So if the duty cycle is less than 0.5, then it will act as which converter? Buck converter, that will be seen. And duty cycle is greater than 0.5, then it will act as boost converter. Okay, and duty cycle is equal to 0.5, then same as the supply voltage, output voltage will be the same as the supply voltage, although the polarity will be getting reversed. Okay, I hope that makes sense. Okay, next we will see the ampere second balance in case of the capacitor. So output voltage is clear to you, that is V0 is equal to minus d by 1 minus d times Vs. Okay, now we will apply the ampere second balance. Okay, let us move the next page. Okay, now we will apply the ampere second balance. That means the average current through the capacitor, that is 0. That means whatever current that is flowing through the capacitor in the charging condition, that will be in the discharging condition, that will be fed. Okay, so in the inductor case we will apply the volt second, and in the capacitor case we will apply the ampere second. Okay, very much pretty simpler. So IC on we have to calculate. So IC on means whenever the switch was on, you see the diagram, whenever the switch was on, no current passes through this diode, because diode will act as open circuit, because it is reverse biased condition, because cathode is connected to the positive terminal of the diode, as you can see clearly, basic sense. So capacitor that was initially charged, so that initial, for the initial charge, the current will be flowing through the output R. So you will apply the KCL over here, the incoming current, that is 0. So 0 equal to IC plus I0. So IC will be equal to minus I0, that is the negative of the output current as per the convenience, as per our convenience, as per the conventional direction. Okay, and here we will see that in the off condition, that means whenever the switch was in the off condition, then what is the IC? Whenever the switch is in the on condition, you see that this current will be flowing, like IC plus I0, that current is nothing but this current. Okay, so IC off, we'll write IC off is equal to, that means the IL current. What was the IL current? It is the IL current, the current flowing through the inductor, that is the IL current basically. So current flowing through this inductor, that is IL. If you apply the KCL over here, then the incoming current, that is IL and IC, and this also I0, so that is equal to 0, or the summation of the entry of the current, that is equal to 0. So IL plus IC plus I0 equal to 0. So IL plus IC plus I0 is equal to 0. I hope it makes sense. Okay, so IC off equal to minus I0 minus IL. So minus I0 minus IL. Now you apply the ampere second balance. You are free to apply IC on into T on plus IC off into T off, that is going to be equal to 0. So IC on, what is the value? Minus I0. And what is the on period? That is duty cycle multiplied by the total time period. What is IC off? Minus I0 minus IL. And T off is 1 minus D times T, that is going to be equal to 0. Okay, T getting cancelled, minus minus getting cancelled, so I0 D plus I0 plus IL into 1 minus D, that is going to be equal to 0. Okay, so our target is to find the I0, so multiply. So I0 into 1 minus D plus IL into 1 minus D, that is going to be equal to 0. So I0 D plus 1 minus D. So I0 plus IL into 1 minus D, that is going to be equal to 0. Okay, so I0 is equal to minus IL into 1 minus D, as you can see. So minus IL into 1 minus D, 1 minus D positive, IL positive, then minus. Where minus? Because I0 current, that was the downward, but actual case that was in the upward direction. The convenient direction is conventional direction is downward, but we have taken upward. The convenient direction that was downward, but the operation that we have seen, that current will be flowing like this. So overall that current will be negative of this current applying the KCL. That is the simplest network analysis and synthesis rule. Okay, so I0 will be minus IL into 1 minus t. Okay, so that is the current case. So now IL max, that is repelling the inductor current, that we will find IL max is IL average, that is IL average, that is IL plus delta IL divided by 2, and IL minimum, that is IL minus delta IL by 2, because graph will be like this, no? This is the duty cycle, on off on off. During the on time period, inductor will getting charged. During the off time period, inductor will be getting discharged, discharging like this. So it is dt and it is 1 minus d times t. Okay, I hope this makes sense. So this is the case, the average, that is IL. Okay, and the difference, it is IL minimum and it is the IL maximum, and difference between IL minimum and IL maximum, that is basically delta IL. So it is delta IL plus delta IL by 2, that is going to be IL max, and IL minus delta IL by 2, that is going to be IL minimum value. Okay, now what is the delta IL? Now in the on condition, we have seen that VL on was equal to the supply voltage. Now what is voltage across the inductor? That is L di dt. So L inductor and di dt can be written as delta I by delta t. So delta IL by dt, that was in the on period, that was equal to Vs. So L is equal to Vs dt, delta IL is equal to Vs dt by L. So Vs d by FL, because time period is equal to 1 by frequency, that we all know. Okay, so that is basically the delta IL value, and IL value we know that we have found out that IL is equal to I0 minus I0 by 1 minus d, because I0 was minus IL by 1 minus d. So IL is equal to minus I0 by 1 minus d. So that value we will put in this equation and we will find the value. Okay, and V0, that is equal to V0 by R, that is equal to basically I0, that we know, simple Ohm's law. Okay, now the critical inductance value. What is the critical inductance value? Critical inductance value means IL minimum should be equal to 0. That means the charging will be starting from the minimum case, in the 0, from the origin. Okay, so IL minimum 0. IL minimum is IL minus delta IL by 2, that is going to be equal to 0. Put the value of IL, put the value of delta IL by 2, you will get the value of the inductor L. In this case, that inductor is going to be LC, that is the C for critical inductance value. Now repel in the capacitor, that means delta Vc. During the on condition, the current was minus I0, so IC on, that is C dV dt, C delta Vc by dt, that will be equal to the minus I0. So delta Vc will be equal to minus I0 dt by C, so minus I0 d by Fc, because time period is equal to 1 by frequency. Okay, so delta Vc will be now the voltage across the capacitor, that will be minimum to maximum. Okay, so from minimum to maximum, that was capacitor charge initial, so maximum to minimum. Okay, so delta Vc, that is going to be V minimum minus V maximum, that is minus I0 by d by Fc. Now V max minus V min, that will be I0 d by Fc, positive I0 d by Fc. Now critical value of the capacitance, where del C minimum equal to 0, that means Vc minus del Vc by 2 equal to 0. Now Vc, you know, Vc equal to key V0. Vc is equal to V0 because the capacitor and resistor was in the parallel combination. So whatever voltage that will appear in the case of the V0, that will appear in the Vc, that means the across the capacitor as per the KVL rule. So Vc minus delta Vc by 2, that is going to be equal to 0. So if you apply the Vc minus delta Vc equal to 0, then Vc value we have found out, delta Vc value we have found out, so you will get the value of the capacitor. So something that will be denoted as Cc, C for capacitance, then and this subscript C is going to be for the critical value. So that was the case of the buck boost converter I have shown you the operation of the buck boost converter, how it can be operated as buck converter, how it can be operated as boost converter, what will happen when the switch is on condition, what will happen when the switch is in the off condition, what will happen the across the output voltage. Now switch current and diode current that you will follow in this step. Whenever the IL is basically the switch current. So during the on condition switch current flows, so this graph will be like this: I switch ISW. During the off condition it is 0, then on condition will get, then off condition 0, and complementary situation will happen in case of the diode current. During the off condition it will go like this, during the off condition it will go like this. Okay, I hope this makes sense. Okay, so if we are told to apply the ISW value of the RMS current, so RMS current is equal to ISW is basically the IL into root over the duty cycle, root over D. If you are told to find out the average value, then IL into D, and IL into 1 minus D in case of the diode current, and if you take the RMS value, IL root over 1 minus D. All the value of the IL is known to you. Duty cycle will be mentioned in the question or hint will be given. From there we can find the duty cycle. So other method you can do. So this is all about the buck boost converter. I hope you have understood the operation and calculation about the buck boost converter. If you have any doubt, then ask me in the comment section. I will reply definitely. Okay. Thank you for watching this video.